All right, growth mindset. Math magician Panthers. It's not the east side or the west side. No, it's not. It's not the north side or the south side. No, it's not. It's the dark side. No, it's not the dark side, Darth Vader. It's the math side. Yes, let's get our math going here. We're going to be looking at differentiating factors and multiples to start off with, and we'll be getting more into lowest common multiple. Just a reminder, sometimes I'm going to let the slides speak for themselves. Shh, Mr. Hoffman, you can be quiet too, you know. Okay. I like to chop things into little pieces. Chop, 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 chop. I like to make things bigger. Big, 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 big. Be a multiple monster. Praise. All that good stuff. Ready? And make these numbers bigger. Make these numbers bigger. Bigger, bigger, bigger. Yes. Look at that growth. Multiple growth. Multiple, 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 multiple. Ah, look out. What? Which group contains multiples of 20? Eeny, meeny, miny, mo. Catch a multiple monster by its toe. Wait a minute. I don't think they have toes. Yeah, I don't think so. Unless they're hiding underneath there. Okay, which one makes numbers bigger? Which one makes 20 bigger? This one. Oh yeah, this is the multiple monster. Yum yum. Let's see, what color would his slime be? Probably kind of like a reddish color, I bet. We'll go with red, right? Slime. I love these numbers. Yum yum. Okay, what are these called? Hi, that's your clue. Hi. Yes, I chop this into smaller pieces. Chop, 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 chop. Oh, and what color would he chop things into? I don't know. Let's just go with blue for now. Although it looks green, it's really blue. See, when yellow and blue make green. Yeah, okay. Can you tell which of these is the factors and which of these are the multiples? Ninja, I chop these into smaller pieces. There's only so many pieces. Monster, I make things bigger and they go on forever. Yes, that's because I am really special. Hey, I'm special too. Okay, maybe we can work together. Okay, we'll be the most ultimate team and we will rule the universe together. Who are you, Darth Vader? Oh yeah, no, I'm Factor Ninja, I forgot. Okay, well, I'll forgive you this time. Don't let it happen again. Okay, hi. Can you find the greatest common factor, GCF, of two whole numbers? Consider 20 and 30. Think about it. First of all, is the greatest common factor going to be less than 20 or 30? Factor Ninja? Or greater than 20 or 30? Multiple monster. Factor Ninja! Break it to small pieces. 1 times 20 is 20. 2 times 10 is 20. 4 times 5 is 20. Let's do the same thing with 30. Right. Now look, which one is the... See, they're all small pieces. But which one is the biggest small piece? Which one is the greatest, meaning biggest, small piece? Because factor is small. The biggest small piece. The greatest small piece. The greatest small piece. Sounds like I'm saying Maltese. That's a dog. Which of the smaller pieces are the same size? The common, the biggest small piece that they have in common. There we go. The biggest small piece that they have together. They have 1 together, 2 together, 10 together, and that's it. Oh, 5. Which one's the biggest piece out of all these small pieces? Height. 1, 2, 5, 10. And which is the smaller? It is 10. Height 10. That's the biggest small piece. The greatest common factor. What about least common multiple? Least is the smallest, but remember, multiple monster is the bigger pieces, which is the smallest of the bigger pieces that they have in common. Okay, first, we must get the multiple part. Make the multiples go. Monster, multiply them. Oh, multiple monster, you are efficient. Ready? Let's do the 30. Multiply him. Now, which is the smallest of these really big pieces? Take a look. There it is. 60 is the smallest of the big pieces. They have 120. They have 100, and they can go on and on. We can go to infinity. The greatest common multiple is infinity, always. The least common factor is always going to be 1. That's not very helpful. So we never really look for the least common big piece. We look for the greatest common small piece. Sorry, we don't ever look for the least common small piece because that's like the smallest of the small. And if we did the biggest of the big, that was infinity. So we did the smallest of the big and the biggest of the small. The biggest of the small, the greatest common factor, the smallest of the big, the least common multiple. Yay! Greatest common factor is the biggest of the small pieces. Least common multiple is the smallest of the big pieces. Now, can you determine the least common multiple of 2 whole numbers? We just did it. We just did it with 20 and 30. Make the numbers bigger. Which is the smallest of the big pieces that they have in common? They have 36 in common. They have 24 in common. They have 12. Least common multiple of 6 and 9. Pause the video, see if you can find it. Remember, multiple means big pieces. Least means the smallest of the big pieces. Here's the bigger pieces. I like to do 3 at a time.